NASA, I get to look at all the cool science that we do across the solar system. Venus, our bad twin, is clearly a place that we need to go back to. And yet, it's really hot on the surface. The atmosphere is super corrosive, so a huge exploration challenge. We still don't understand why Venus is so different than the Earth. Is it because it was just that much closer to the sun? Maybe, but I think it's more complicated than that. Titan is this other body in the solar system that has really fascinating things to tell us about the Earth. The fact that Titan is the only other body in the solar system that has a liquid cycle not that different from our own hydrologic cycle, an active liquid cycle where it rains, there are seas, there are rivers. So to me, Titan is that way, that push on our model, our Earth-based model that water is necessary for life. Titan has these oceans of liquid ethane and methane. They've been stable, we think, for thousands and thousands of years. Could life evolve in the seas of Titan? Europa, of course, is a moon of Jupiter. It has this thick, icy crust, but underneath that icy crust is a liquid ocean. The center of Europa is being pulled on by Jupiter, just like Io is. So we think that rocky core under the liquid ocean, under the ice crust, is probably volcanically active. So then we start thinking about things like black smokers, these environments on the surface of the ocean here on Earth, where you've got volcanism. They're extremely rich environments for life. Just think if that's inside Europa. How cool is that? Enceladus, one of the moons of Saturn, it also has an icy crust, subsurface liquid ocean. Enceladus, how great is this? Enceladus spits its ocean at us on a regular basis. It has these geysers that erupt from the surface. We've actually taken the Cassini spacecraft and we've flown through those geysers at a pretty low altitude. So we've been able to sample the material coming out, so we know there's liquid water coming out, it's actually salty, and we know there are complex organic compounds also in that liquid coming out of Enceladus. To me, learning about the sun has been fascinating. Obviously, we have huge concerns over our ability to monitor the sun, try to get early warning as much as we can back to the Earth from a practical level. Can we start looking at when the next solar flare could be? What area of the sun is it coming from? They're making strides in this, but there's so much fundamentally about the sun that we do not understand. Fascinating, crazy physics that I think the sun remains an incredible scientific challenge, an incredible exploration challenge. Each of these targets really has something to tell us about that issue of where did we come from, where are we going.